is about the numpys. See, firstly, the numpys is a concept when it comes to the Python programming language. See, the Python programming is one of the mostly used and famous programming language. It is also a easy one to easily understand, to simply learn, and to inculcate in us. It is also mostly used for creation of many applications, also for the creation of many programs like the software for the ATMs and the swiping machines, still many more. Also, it comes in the EVM's creation also. So firstly, the NumPy. Let's start with its introduction. The NumPy stands for the Numerical Python. It is one of the most fundamental, powerful, and core libraries in the Python ecosystem and used for scientific computing, data science, and machine learning applications. See, Python is considered as a gateway for the AI. AI stands for the artificial intelligence. In today's world, since approximately 2 to 3 years until present, also still many more the future time, the AI is playing a key role at present. It has reduced many of the software jobs. Also, in every aspect, AI is taking place. So that's why the Python learning is very important. As in the NumPy, its heart NumPy provides a high-performance multidimensional array object called ND arrays. At its heart, NumPy provides a high-performance multidimensional array object called ND array. The ND array is a dimensional array, n-dimensional array, along with an extensive collection of tools, high-level mathematical routines, and optimized algorithms to operate efficiently on these arrays. So why not just use regular Python lists? See, there's a difference between all of them, so let's understand it clearly. The standard Python lists are highly flexible because they can hold elements of different data types which are heterogeneous. However, this flexibility requires significant computational overhead because each element is a complete Python object with its own typing info, that means the information and reference counts. Conversely, NumPy arrays are homogeneous. That means all elements must be of the exact same data types, example, the integers or the floats. This allows NumPy to store data in continuous blocks of memory, leading to massive speedups and minimal memory consumption. This leads to the massive speedups and minimal memory consumption. So this is the box which I stated now. So please note it down. It carries more marks. So next, where is the NumPy used? See, often we will be having a doubt where we have to use this NumPy. The NumPy serves as a bedrock for almost all major data science and computational libraries in Python. If you are doing data analysis, engineering, or AI, you are indirectly using the NumPys. Major fields of the applications include the data science and analytics. That means it forms the base foundation for pandas. The pandas often has the data frames and series. It is a combination. And next one, the machine learning and deep learning, ML and DL. It is the high-end ML DL framework libraries like scikit-learn, TensorFlow, and PyTorch uses the NumPy arrays under the hood to store datasets, weight matrices, and handle tensors. Image processing. Digital images are represented fundamentally as a 3D configurations of pixel intensities, height into width into RGB channels. NumPy makes manipulation of these grids extremely quick. The linear algebra and signal processing. Used heavily in matrix computation, solving systems of linear equations, Fourier transforms, and wave data manipulation, quantum computing and simulations, handling multidimensional state vectors and complex matrix vector probabilities. See, the quantum computing. See, we almost all of us know that the supercomputer is a type of the computer which can process or solve the complex programs within very less time. See, the computer itself can solve the problems in less time. The supercomputer is still much more efficient than the normal computer. When it comes to the quantum computing, It is still more efficient and more easy one to complete the given tasks. The machine learning, as you stated before, the machine learning and deep learning, it is being widely learned by many people because in the developed countries also as well as in the present situation in our country, the deep learning and machine learning is used to create various kind of the softwares. See, we often know that in the automatic cars, they does not require a person to drive them. It automatically drives, it automatically moves on. See, the behind software, the behind the programming is of the machine learning and deep learning. So next one, the key functions of the Numpy. The key functions of the Numpy offers robust built-in functions to initialize arrays quickly and retrieve structural metadata. The array creation functions, np.array, np.array. See, the np stands for the Numpy. See, we cannot always import, we cannot always state to come the Numpy. See, it is of the huge one to always call that. Instead of the whole name Numpy, we are using np. It is the alias name. It is the alias name. See, the np is the alias name for the Numpy. The Numpy offers robust built-in functions to initialize. The np is the alias name. The np.array, we are calling the array with the alias name of Numpy, np.array. It converts the standard Python iterables, the lists or tuples, into the structured arrays. np.zeros, it generates an array entirely filled with the zeros, excellent for structural pre-allocations. See, here we have given a shape. See, that means a preferred a kind of shape which we ask, it provides. In that shape there will be only zeros. np.ones, there will be only ones, not ONES. That means the numerical character, the 1, and for zeros it will be 0. For ones, it generates an array completely filled with ones. Next one, np.arrange. See, we all know that arrange spelling is ARRANG, but when it comes to the Numpy, its spelling is of ARANGE, np.arrange. See, here we can either start with the start and stop, but here we often use the start, stop and step because the start is of the index value and the stop is of the n-1 value. See, we all know that index value starts from 0 to n-1. See, this is the 0 value, this is the stop is the n-1 value, the step is the required value. Like you can also step from 1, 2 and many more. It generates the sequences of regularly spaced numbers within a specific numeric range. Next one, np.linespace. Here also given the same thing, the start, stop, step. It generates a specified number of evenly distributed values over a specified geometric interval. Next one, the array metadata inspection attributes. See the metadata. The data is a collection of the facts. The metadata requires all the metadata is said to be as the data. I mean, the data subpart is of the metadata. The ndarray.shape, it returns a tuple indicating the dimensions of the array. Example, it will be in the rows and columns. ndarray.ndim, that means the n dimensions. It returns an integer indicating the total count of dimensions. The axis. Next one, ndarray.dtype. Dtype stands for data type. This means it inspects the exact internal data type of elements sorted inside. Next one. Here comes the core concepts of the Numpy. So one of the strongest features of the Numpy arrays is vectorization. Vectorization allows the code to execute element-wise operations directly in optimized C backgrounds without running tedious, slow Python for loops. See the loops we often know there are the loops are of two kinds in Python. They are the for loop and while loop. When it comes to the C language, we are having three types. While, for, do while. Also there is one more loop, do loop. When it comes to the Java, we are having the same loops. Only for Python, there are two loops. They are the for loop and while loops. Next one, the element-wise arithmetic operations. Arithmetic operations apply element by element over matching arrays. They are. Here you can clearly see. Please note it down. It's very important. Next one. The broadcasting mechanism. It is a powerful tool allowing arithmetic operations to run smoothly on the arrays of completely different shapes. Numpy expands the smaller array across the larger shape dimension dynamically behind the scenes without creating costly duplicate copies of data. Next one, the matrix multiplication. See the matrix multiplication which plays a key role in any kind of the programming language. The data is stored in the form of rows and columns. The true dot products and matrix operations are easily executed via the at operator or the np dot function. The essential methods in the NumPys are the built-in methods which are used constantly to transform data shapes or calculate the summary statistics. You can clearly see here we have provided you a table which consists of the method names, the core behavioral description of the purposes. The reshape, flatten or ravel, transpose, sum, mean, std, min, max. See the sum, mean, standard deviation, min, max. These all comes under the statistical operations on the NumPys. Next one, the comprehensive practical example program. We have provided you an example program which can help you to understand about the NumPys in an easy manner. Okay, let's go to the program. Please note down the program. It plays a key role because in many of the exams, if you are studying in degree or BTech, you will be often having the mid examinations, also the internals and many more, which can be helpful for you. If you note it down, it will be helpful for you to understanding and also to practice. See, firstly, we are importing the NumPy as NP by its alias name. Now, the NP is the alias name of NumPy. We are using the as keyword to import that. The import keyword is also used. See, firstly, we are creating the arrays using the regular Python lists. See, the list, this is the thing which we are importing the four things. The demonstration of the vectorization. There are no loops needed for this one. And next, we are generating a two-dimensional matrix structure via the reshape. We are performing the matrix multiplication through using of the dot product. And the descriptive matrix aggregations are given here. See, note it down, it's very important. The NumPy achieves its extreme execution speeds primarily through contiguous memory allocations. That means the CLOC. The CLOC comes in the dynamic memory allocations and by leveraging highly precompiled vector loops written in low-level C language. Mastering NumPy arrays is the absolute first milestone to entering professional data science, analytics, and engineering fields successfully. Okay, thank you. That's all for today.